Welcome students. In this video, we're going to learn how to find limits graphically. So a quick review from my last video, we learned about limit notation. We learned how to read it and write it. So this is read as the limit as x approaches a of f of x is b. But in that video, we also discussed how you can approach an x value from two different directions, from the right or from the left. So because of that, we have a right-hand limit, which is approaching from the right, and a left-hand limit where you approach from the left. So let's start with the right-hand limit. The notation for right-hand is marked by this little plus sign up in the exponent on your approached x value. So in this case, a to the plus. So we read this as limit as x approaches a from the right of f of x is b. So let's look at a practice problem. If this is my graph g of x, I want you to take a second to ask yourself, what do you think the limit of g of x as x approaches 3 from the right is? So the limit of g of x as x approaches 3 from the right is 3, because approaching from the right means coming from the positive infinity side of the x-axis. So coming from this side and walking down on my function, I can see as my x value gets closer and closer to 3, my y value is getting closer to 3 as well. So we write this as the limit as x approaches 3 from the right of g of x equals 3. Now, for the left-hand limit, it's very similar. The difference is that we have a minus instead of a plus sign to note that this is the left hand. So we would read this as the limit as x approaches a from the left of f of x equals b. Let's go back to that example g of x. I'm going to give you a moment to think about it. What do you think the limit of g of x as x approaches 3 from the left is? Remember right here, this is x equals 3. And the correct answer is 1. Because when you're approaching from the left, that means you're coming from the negative side of the x-axis, from negative infinity side. If I were to come from this direction and go towards x equals 3, then I would be approaching the y value of 1. And we write that as limit as x goes to 3 from the left of g of x equals 1. So it's important to note that since the limit of g of x as x approaches 3 from the right is not equal to the limit as we approach from the left, that means that our general limit, just the limit as x approaches 3, does not exist. So we'll write the limit as x goes to 3 of g of x, DNE, which stands for does not exist. Which brings us to our notation for the general limit. This is actually the notation that you learned in our previous video, right? The limit as x goes to a, no plus or minus. And the only difference now is that we know that when we have the limit as x goes to a of f of x equals b, that means we're approaching a from both sides, from both directions, the right and the left. So I want to do some practice, but before we move to practice, there are two pieces of essential knowledge that we have to know. The first is that if your right-hand limit equals your left-hand limit, and they're both equal to b, then that means your general limit is also equal to b. However, if your right-hand limit is not equal to your left-hand limit, then that means your general limit does not exist. Armed with this essential knowledge, let's move to some practice problems. All right, let's look here at part 1. Use the graph to estimate the limits below. So I have a couple limits here. You can see that everything is going to be evaluated at x equals 2. So I'm going to be looking very first thing at x equals 2. That's what I know. Now, f of 2 is not a limit, it's just an evaluation. So it's asking you, what is f when x equals 2? So when x equals 2, I gotta find my y value. Notice how I have two different points, but one is an open circle and one is a closed circle. The closed circle is always the defined value. So f of 2 is going to be 4. Let's move to the limit as x approaches 2 from the right. Remember, that means we're coming from the positive infinity direction and going towards positive 2. So I'm up here on my function. I'm getting closer and closer to x equals 2. And what am I approaching? What y value am I approaching? Well, it looks like I'm also approaching 4. Now let's move on to our left-hand limit. I'm going to use a different color just so it's really clear. We're going to move to our left-hand limit. And that means we're coming from the negative direction, walking towards positive 2. So I'm going along my function. And as I'm getting closer and closer to 2, it looks like my y value is also getting closer and closer to 2. So this left-hand limit would be 2. That leads us to our general limit, and this is where we need that essential knowledge that I just gave you, right? We'll notice that our right-hand limit is 4 and our left-hand limit is 2, which means our general limit, or the limit as you approach both sides, actually is not equal to anything. It does not exist, okay? General limit does not exist because your left and your right-hand limit are not equal to the same number. Let's move to another example. This time we're looking at the x value, x equals 1. So we got f of 1, the right hand, the left hand, and the general limit as x approaches 1. So starting with f of 1, we're going to just go to where x equals 1, and we'll see that our y value is equal to 1 at that point. So f of 1 is... Now we're going to look at the right-hand limit. So that means we're coming from the positive infinity side. We're going to come from this direction. You might be confused that we have a little jump right here, but that's okay. We can jump right down and just keep approaching 1, get close to it as possible. And notice that as we're approaching 1 from the right-hand side, the y value that we're approaching is also 1. So this right-hand limit is 1. Let's look at the left-hand limit now. We're coming from the other direction. I'll use orange to show this. Coming down from the left direction, getting closer and closer to 1. What y value are we approaching? We're still approaching 1. And now that we've gotten to the general limit, we can use some of our essential knowledge. So we know that the right-hand limit is 1 and the left-hand limit is 1, which means the general limit has to also be equal to 1. And you may notice that f of 1, the right-hand limit, the left-hand limit, and the general limit are all equal to 1. So this means that this function is actually continuous at x equals 1. And we'll get there, we'll learn more about continuity in our next topic, but I just want to let you know that since all of these are equal to the same thing, that means that your function is continuous at 1. All right. For our last example, you can see that we're evaluating or finding the limit as we're approaching x equals -1. So I want you to take a moment and look at this graph and ask yourself, what graphical feature do we have at x equals -1? I'll give you a moment to think. At x equals -1, we have a vertical asymptote. So since we have a vertical asymptote here, our limits are going to be equal to slightly different things than they were before, but that's okay. The essential question that you ask yourself, as x gets closer and closer to -1, what does y get closer and closer to, will still work for this vertical asymptote. So let's go ahead. We know that for f of 1, it's actually not equal to anything. It is undefined because we have a vertical asymptote. Now let's look at the limit as x approaches 1 from the right. And you'll notice that as my x is getting closer and closer to -1, my y value is not approaching a single number. It's actually going upward, increasing towards positive infinity forever. So your limit is actually going to be equal to positive infinity. Now let's look at our left-hand limit. We're coming from the left side, from the negative infinity side, going towards x equals -1. And you'll notice the exact same thing is happening on the left side. We're not approaching a single y value. We're actually going up, increasing towards positive infinity forever as x is getting closer to -1. So our left-hand limit is also equal to positive infinity. Now, calling in our essential knowledge, we know that since the right-hand limit is positive infinity and the left-hand limit is positive infinity, that means our general limit must also be equal to positive infinity. All right, thank you so much for tuning in. I hope that video helps you find limits graphically, and happy studying.